Hello. So this video is on approach statements, and I'm going to go over an example and use approach statements so you can see how to write them and how they, what they mean. So here we're going to graph Hein of x. Here's an example similar to what you might see. And I use Hein of x just to emphasize that a function name can be anything. So it's f of x, we call f, so forth. But graph Hein of x, and this is the function here. Now we want to simplify this first by factoring the top, which is going to be x. The only numbers that go into 5 are 5 and 1, which is great because they make up 6 by doing plus 5 and plus 1, which if you check that 5x plus 1x is that 6x. And bottom is x plus 5. And since these are the same, x plus 5 divided by x plus 5, that's just going to go to 1 because anything divided by itself is 1. So what we end up getting here is Hein of x is equal to x plus 1, comma, where x can't be -5. And that's your domain. So this little review is if they are the same, that means that that's a whole. An asymptote is if you can't divide out the denominator. That is a vertical asymptote, that is. This is a little review. So we're just graphing x plus 1, which means it starts at 1, goes up 1 over 1 every time. That's a pretty easy graph to do here. But there's a whole at -5. So -1, 2, 3, 4, 5. I'm going to make my graph go up far enough. It doesn't get in the way of anything too much. There is a hole here, which that hole is at -5, comma -4 if you plug that in, just so you have a better idea of where that hole exactly is on that function. Okay. Now, approach statements is writing as something as this. As x, or your input, approaches, and in this case, let's say as x approaches -5. Now, there's symbols they can use where if they put a little negative in the top, that means from the left. So as x approaches -5 from the left, so from my left side, as I'm on the function, I'm on this line, as I get closer and closer to -5, I'm approaching what number is that? Well, that's -4. So you'd say y approaches -4. And you could use letter symbols to do this. So you could do as x approaches 5 from the left, -5 from the left, y approaches -4. That's saying the same thing. Those are equivalent. And that's the symbol for equivalent in higher math classes when you get into proofs. You could say as x approaches, because again, there's no questions here guiding us on what to say. I'm just going over some stuff. -5 from the right. So from my right-hand side, as I'm on the function approaching -5, which is here, well, I'm actually at, where am I at when I get here? -4 too. So y approaches -4. I should have not used letters. I should have said x approaches -5 from the right, y approaches -4. Now, do note that if there is no positive negative symbol, if it was just as x approaches 5, that's assuming the left and right meet up. Assuming both. In which case, in this case, we could do it because it exists. We could say that x approaches 5, y approaches -4 because they're both -4, but that's not always the case, in which sometimes that doesn't exist. We could put as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity, and we could see that there as well. Okay. So that's how approach statements work. It's just a way of writing them, and I hope that makes more sense to you. Let me just look at your problems again, make sure I'm not missing anything or saying something wrong to you. Yeah, that's the idea there. So good luck on this assignment, the rest of it. I kind of talked about holes, vertical assignments, and how to graph those. Hopefully that helps you a little bit more. If you have questions, you know what to do. Bye-bye.